And we're back here, continuing our discussion on polar curves. So in the previous lesson, we looked at how to find the symmetry, how to look at the symmetry of a polar curve by replacing theta with something else and testing to see if you got something equivalent. In other words, if you got simplified and got back to our original equation, that was symmetry. Here we're looking at finding the maximum R value. This could be thought of as the same in rectangular world as finding the maximum Y value. So here we are finding the maximum R value because R depends on theta. You see I have absolute values around R, and you'll see why that's the case. So later on in the video. So let's begin by first recalling something that we will definitely need in order to find the maximum R value. We will need to remember that the sine function falls between -1 and 1, as does cosine. Cosine of theta falls between 1 and -1. This is going to be critical for us to test and find this maximum value. So let's begin. So find the maximum R value of, let me write this down, find the maximum R value of, let's do R equals 3 plus 2 cosine theta. So this was the example we began with in the previous lesson, in that we found that it was symmetric with respect to the polar axis. We know how the symmetry here. So now let's test this out. That's the first thought. Let me add to this. Not only let's find the maximum R value, let's also find the values of theta that yield these values. Okay, we'll address that after finding the maximum value. So, if we set cosine of theta equal to +1, okay? So we're going to test the +1, and we're going to test -1. That's what we get. So 3 plus 2 times 1 equals, well, 5. All right. And let's test if cosine theta equals -1. Okay, so R equals 3 plus 2 times -1. That's going to be, well, +1. Okay, so this would say that the maximum R value is 5. So before we address the maximum R value, we're going to say, therefore, the range is from +1 to +5 with a maximum R value of 5. Okay? And the reason why I say, again, the absolute value, addressing it right here. Let's say that I went from -6 to 5. Okay? Because a negative radius simply means how it's positioned with respect to the pole, a -6 would still be considered a larger radius than the 5. Okay, so that's why we take the absolute value. So we're looking at the magnitude, the size of the number. Okay, so let's look at, well, really, well, we didn't finish the problem. So we have the maximum value of 5. And let's look at, sorry, my wife was just looking at me in the window, making a weird face. Okay, so moving on. So let's say we had, well, what if the R is 5? So we're test for theta. So if R is 5, what theta values give us that point? So we subtract 3, divide by 2, and yes, we get 1. Maybe you might have known that. We would have gotten 1 through simplifying. So taking the arc cosine of 1, that would give us theta to be 0 pi. or 2 pi. So since theta is 2 pi, we say exactly 2 pi, oh well, our point is going to be 5 comma 0 pi. So at that point, we are the furthest away from the pole. That's what we can say here. This is rather easy. It's replacing cosine or sine with 1 and -1, simplifying and looking at the largest number in terms of magnitude. That's it. So let's look at one more example. So what if we had, thinking of complexity, how far I can get in terms of difficulty, what if we had, same question, it's another example, same question, but if we had r equals 2 cosine 3 theta, all right? 2 cosine of 3 theta. So it could be sine or it could be cosine, it doesn't matter. So let's say if cosine is, well, 1, what does this mean for us? So if cosine is 1, 2 times 1, it's going to be 2, okay? And if cosine of theta equals -1, well, r equals 2 times -1, and that's going to be -2. So the range for r is going to be from -2 to +2. So our maximum r value is 2. Okay, so now we're going to substitute that back in. So this is where we test for theta. So we substitute 2 back in, we use a different color. 2 equals 2 cosine of 3 theta. Divide by 2, we get 1 equals cosine of 3 theta. So because we have a 3 theta within the cosine function, when we take the arc cosine of 1, it is going to equal 3 theta. All right, so we're thinking cosine is 1 when? Cosine is 1 at 0 pi. Okay, so 0. Cosine's 1 at 2 pi, at 4 pi, at 6 pi, and let's say 7 pi. No, not 7 pi, 8 pi. So you might be asking, why did you go all the way out that far? I mean, isn't it just 0 pi and you're done? If I was left with just theta, yes, but we have 3 theta here. So now we have this long list, because what I'm going to do is I'm going to divide each of these by 3 until I get an angle measure that's above 2 pi. So 2 pi is the end of our domain, and once we get past 2 pi, I'm just going to start disregarding it. So let's do this and see what happens. So we divide by 3 and we get, well, 0 pi again. We get 2/3 pi, all right. 4/3 pi. We divide 6 by 3 and we get 2 pi, and that is where we stop. Okay, so in this polar curve, r equals 2 cosine 3 theta, we have 3 angle measures that give us our maximum value. So these are the 3 values that yield max r value. So our coordinates would be, let's see, +2 comma 0 pi, +2 comma 2 pi over 3, and +2 pi comma 4 pi over 3. And there we go. We're done. So this problem required a little bit more in terms of finding the angle measures, only because it had an inner function. If I did not have an inner function within the cosine or sine, I would be done here. Okay, so we now, by this point, know how to find the symmetry of a polar curve, how to test it, the 3 different ways. We know how to find the maximum R value. I'm hoping it's simpler than what you thought it would be. Just knowing the highest and lowest that sine and cosine can go. And then once you find the maximum R values, finding the thetas that yield those maximum R values. So we're going to continue on, and we're going to look at all of the, well, not all, but some various polar curves and by their name. So I haven't been giving you the polar curves and the name for that type. So we've looked at, in this video, 2 polar curves. In the previous lesson, I believe 3 polar curves. Each of them have a name, and in the next lesson, I'll share with you those names, what they look like, and how we can test symmetry and max values for that. So good luck. I believe you're going to be practicing finding the maximum R values and the thetas for those maximum values. And I'll see you in the next lesson where we get to actually look at the names of these graphs.